Good afternoon, everybody. Good afternoon. Can you hear me? Thank you. Okay, let's give it a minute until your classmates arrive, and then we will um, head on. Has anyone has any question about the previous lectures? Do you have any questions about the previous lectures? Anything we had covered through the materials and you feel that you're not confident, something is not 100% understood. One last time. Anyone had questions? Anything you had read, watched, attended, and you didn't understood so far since week 2 until today? Any concept, anything you didn't understood? No? Okay, so let's move on to today's lecture. I'm not sure if you have heard about the recent attack on Canvas, which took place 2 days ago. There are 9,000 bodies, educational bodies, either universities, institutes, schools, and so on, had been affected. Someone hacked that cloud-based services and put everybody out. They said that it's ransomware. Some people ask for money. However, that's not our concern for today, if it's what type of hacking. The idea that it has been hacked already. So, how we protect ourselves against those type of attacks? How we provide security? Well, for individuals like us, we usually use what we call that host-based firewall, or what you call it antivirus software. In some textbook, they related the host base to servers, standalone devices, or even personal computers. or personal devices in most textbooks. Today, we will put them into different classification. We will put the host by itself and the personal firewalls by itself. So what we do to protect ourselves? Well, we protect ourselves using different type or different naming, different classification of firewalls. And that's what we will cover for today. What is a firewall in general? Well, firewall in general is either hardware device or software or cloud-based to do what? To filter traffic goes in and out between the inbound and outbound. What are those ones to make it easier for you to understand? This is the internal network. That can be your home network. That can be a small business, can be a mid-size company, can be a jumbo-size company, can be a government, and so on. However, it is a network. That's the internal network. Outside, usually we represent that by the ISP and the cloud and so on. And that's open. So there is a lot of traffic happening here. And I don't have any control outside here. And that's the outbound, which is anyone here can do a lot of things and send it through the ISP to my network. So what we usually do, we use what we call it a firewall. Can be hardware, software, and can be a cloud, which is a software as well, but cloud-based. And we have different type of firewalls. Okay, so what is the concept, how that firewall works? Well, it filters the traffic from me outside and from outside to come into the inside. Based on what? Based on different type of services and concept as well. For example, we put what we call that secure policy. The secure policy, who authorized in and out, and what authorized, who and what. So that's usually the company or the corporate or whoever set or configure the firewall, try to put those rules, what we call it rules. This is usually under what we call that security policy. Who allowed in and what allowed in as well, and out as well. To do that, usually companies and corporate, they have something called layers of defense or defense in depth. What's that, the concept of the layers of defense? To understand that, let's assume this is the cloud and this is my network. And here it is, that's my router or whatever it is. So now you have a lot of uncontrolled activities here. I want to protect myself. Well, okay, so I'm gonna put a firewall here on the router. Usually the routers, by the way, they have built-in firewall, but it's not enough for us to depend on. So we put our firewall as well here before it walks in. Here is the issue. What about if someone penetrate through that firewall? So the whole network will be open. No, it's not. What we usually try to do, we do different layer using different technical mechanism. So I filter with an option. Someone managed to pass through here. I put another filtrations or another mechanism, different mechanism. So whatever you are using here, you will not use it again here because someone already penetrated. So if I penetrate A, I'm going to penetrate B. That's easy like that if they are similar. So what we do, we put different technique, different mechanism to secure our network. So if someone penetrate that, will be surprised to find something else, something different to be able to face if he or she wants to cross to the internal network. We call that layer or defense in depth or layering, security layering in shape of layers. So how the firewall works usually? Well, this is the external, that's the internal. Here we program what we want to allow, what we want to stop, or what we want to allow and then the rest blocked. Okay, so what you try to block, and here is the idea. We can program the firewall to filter based on IP addresses or protocols or traffic. We call that like different type of services. So we have different type of firewall, yes, but these type of firewalls usually use different mechanism. What those mechanism are? Well, we go to the that's why we need firewall. I think that's you can add whatever you want from your own. So why we need firewalls. But what we filter based on, I can filter based on IPs, and that's usually layer 3. Or I can filter based on protocols, and that's layer 4, layer 5, layer 6, layer 1, go on. Or we can filter based on actually the identity of the user. Really, yes, we do that. And there is an advanced one, which is as well, we can filter based on the behavior of the bandwidth and traffic. Not covered here, but we call that behavior control, but not covered here much. So we can filter actually based on activities. So traffic goes very quick, very down, ups and downs, goes up very high, go down very high, very short, very quick, and so on. We can involve, we can program specifically the smart one, the AI firewall currently can handle that. So we can filter based on IPs. We can filter based on protocols. We can filter based on services like web services, mail services, FTP, audio, video, whatever. We can do that. We can filter based on multi-type of services, even with applications as well. In addition, sure, to the users. So if I want to block a specific user or some users, we can do so as well. How that usually works? We divided the network to inside and outside, internal and external, inbound and outbound, all the same, all do the same job. So my job, not just to only to allow traffic from in to out, and block all the traffic coming back. No, no, no. We need to allow some traffic as well from out to in. So the firewall job is not just to allow in to go out and nothing from out to in. That means we will not be able to communicate totally with anybody. So what we want to do here, we start programming some type of rules, what we call rules. I'm going to show you some of those ones, how it look like after it being executed. What is the cons and pros for the firewalls? Well, the cons, expensive, mostly. Some of it complex to be configured, not easy. Don't get me wrong. It's work on the outside here. However, whatever happened inside the network, it didn't cover it. So it actually protect me from outside, but it didn't protect me from inside. That's one on the thing. So, and actually it says vulnerable to some certain attacks. So some hackers, they manage to do what we call bypassing the firewall. Some about routing, some about specific type of fragmentation, which is micro packet, and so on. So that's what some of it with the cons. Another problem with, if you understand the concept of NAT, which I hope so. So the concept of NAT, in very short for those who maybe this is the internal network and this is the external. That's the router here, or that's usually the NAT. If you are home right now, or if you are at the campus, you will find that your IP addresses usually start with either 10 or 172 or 192. Those are the private IPs. Sure, 10, 10, 10, the 172.16, 192, 168, and so on. But in short, it starts with those numbers. Those are the part of the private IPs, which means that the IPs which I can use it within a LAN. However, those IPs are not routable outside on public infrastructure. So in short, nobody knows you if you cross that. Nobody knows any IPs. For example, my IP is 10.10.10.10. As soon as it's come over here, if it pass that router, nobody knows you here. Fully. So what we do, the ISP provider provide you with public IP addresses. So in short, that IP map to a public and been sent. Those guys, they know the public, so they send you the message back to the router. The router map it back to the private. So it become like this: private to public, public to private. So who does that? The net. So someone has to map. Map means encapsulate, de-encapsulate, which means take the private IP and put the public, take the public, put the private. When we do that, and we have encapsulation and encryption when we use something, for example, IPsec or GRE or whatever, that's create a lot of trouble when we communicate from outside to inside. Net. So if I have encrypted packets and goes and back, here the firewall create a lot of problem for us when we use net as well. For the pros, put whatever you like. For the capability, it provides security. Yes, it filter somehow. Yes, maybe it creates some delays, but we can accept that. It protected the system against the spoofing, against unauthorized access, some IPs, some services, and so on. So feel free to put that's it provide a lot of services as well and protections. What type of firewalls we are using? Well, the famous one, which is the packet filtering firewall, as well the application level firewall. You guys may be familiar with that. Maybe yes, maybe not. But from the name itself, you can guess. So if I go with the packet filtering, the packet filtering usually, as soon as we mention the word packet, it means that we are in layer 3. The datagram naming is we are in layer 3. So that's packeting. Okay, that's how it is? No, because layer 3 usually link as well with layer 4, which is TCP and UDP. So what we have a technique to scan layer 3 and layer 4 and block and allow IPs to pass through. And usually we have that mechanism to allow, drop, discard, and forward. Allow, drop, discard, and forward. So here we have mentioned to you the discard and forward, which is discard means drop without information, without info to the receiver, to the sender, and the forward if you want to forward that packet. Okay, so you put rules. Can you allow that certain IPs, which is, for example, I'm dealing with, let's say 172.16 0.0/16. Allow those ones. Who are those ones? That's the internal network of CQ. So we allow them. What about the rest? Block. Really? Yes. That's how it is. That's how it is. So if someone from using any type of proxy within the campus and try to log to with any IP different from our IPs, that IPs will not be able to go anywhere. That's how it is. That's how it is. Even from internally, like that. From outside, you can block whatever the public IPs you think that it's maybe harmful. TCP, UDP, the same thing. We can put so. However, the concept here is we cover in week 2 the encapsulation and de-encapsulation. And we mentioned that the layers. And we mentioned that adding header, we call it encapsulation. Removing header, de-encapsulation. So what's the packet filtering firewall do usually? Scan the headers. So usually the PDU, something like this, part of it data, and part of it the field as well, different type of fields. Here, what we care about, the source and destination. And sure, you have the ports, whatever the port number, and so on. This one, you have the source IP and the destination IP. When we using the packet filtering firewall, the main goal, the main scan of that packet filter to scan this area. Yes, we have advanced one which scan the data as well. This is the data, whatever the data you actually want sent. But the main goal here to scan the source and the destination. for either IP and sometimes some protocols. Why is that? Because in packet filtering, we try to allow or prevent some certain IPs and some certain protocols as well. So that's the main goal. I scan that. If the scan the source. Is that source allowed or not? Allow, not discard. That's how it is. That's how it is. Easy as that. And this one usually not that advanced. Don't get me wrong. This one it's not that really advanced to be used. But that's used to be one of the top usually. It's look like this. The rules. You have sets of rules, rule A, B, C, D, E, whatever it is. However, let me take you to one of them, which means you can actually see how it works. If I want to allow or prevent emails, so what is the action here? Allow. Allow what? Our host. Asterisk means everybody in our host. What is the port? Every port. Their host, whatever it is, in port number 25. Port number that's 25, that's SMTP. That's the one which is send email. Sending email. What about here? Oh, okay. Allow our host, the ports. Here it is. That's our packet to that port. Allow our host outgoing. Okay, but this one, they mention allow to the port greater than 1024. Okay, so what is that rule for rule set E? What is that exactly? Oh, to understand that, the ports usually we have what we call that the known port, which is from 1 until 1023. From 1024 until 49,000 something, from 1024, we call that registered. Those ones from 1 until 1023, that's the port which is been already known for protocols like SMTP, the HTTP, HTTPS, and so on. But that one from 1024 and up, that's reserved for services. Yes, for example, if you're familiar with the SQL, MySQL, and so on, it works on a specific port beyond 1024. So if you try to put it under 1024, most likely it will not work. So can you allow that as well? In short, if you want the packet filtering, you can put different type of rules. Rules for IPs, different type of IPs, whatever it is. Rules for protocols, rules for services. Later on, you will cover that as well. Or for here only, for this part or the packet filtering only, we will focus on IPs and protocols. What type of protocols are those ones? What's the attacks and the countermeasures of the packet filtering, for example? Because each one of those firewall has cons and pros as well. With the IP addressing spoofing, that's one of the technique. The word spoofing, I think you're familiar with. I hope so. So spoofing means faking. So someone fake an IP, someone fake MAC address. The same thing with MAC spoofing. So faking. Someone tried to put the IP address, which is non-genuine, to a genuine IP address. Not allowed to look like if it's internal IP, not external IP, for example. We call that IP spoofing. Another approach, which is can be go through around that type of firewall, we can this the sender from here. You have different type of let's see. Let me just give you a routing. That's the receiver. So from here, what we do in the sender can specify specific route, which is means that, for example, you put the firewall here. I can send that packet to take that direction. Really, yes. That's a very simple example. But the reality is, if the hacker or the attacker knows where is the firewall and which area the firewall located, and found any other routing path around it, that's what the hacker will do. We will, or the hacker will decide it let's say, decide programmed, pre-coded, pre-configured path to that packet to take. So it goes around the firewall. And that's the source routing attack. The third one, another attack, we call that tiny fragment attack. In short, I think we cover fragmentation before, if anybody still remember. If I have any data and that's data more than the MTU, what the system will do, will break it down into smaller pieces and put the sequence acknowledgement and then put something called flag. And at the end, break it down, send it through one or different directions. And since it has sequence, when it arrives to the other side, it rebuilt again. That's fragmentation. So bigger size more than the MTU, break it down into smaller pieces, which is enough for the MTU, send it through different direction with different sequence, with consecutive sequence. Then when it arrives to the other side, the system will rebuild it and put it back again. In our case here, if the hacker want to avoid being scanned, what they do, they break themselves the packet, even if it's not greater than the MTU, even if it's smaller than the MTU. They break that packet, even smaller like that, into smaller ones. And in here, in the first one here, they try to make the scanner be busy with this, the first one, and let's say overlooked the rest of them. Skip. So make the scanner busy with this one. So when the scanner is busy, we'll overlook the rest of those fragmented, smaller size ones. Away from your study in total here, but you need just only to understand the concept only, nothing else. That's one type of the firewalls, which is the packet filtering firewalls. What is the advantage? What is disadvantage? And as well, what type of attacks it can directed to the packet filtering. Up to here, do you have any question? Any questions? Anything is not clear? Let's jump to the second type. The second type of the firewalls, we call that the state inspect firewall. Let me take you to the third one faster. I think it's better. Just only let me, since you guys familiar with what we call it applications. The application exactly as it said. So it's work on application. However, it acts as something called relay. In week 6, you guys came to a lab like the HCP lab, and you have understood a little bit, week 7, understood a little bit that what is DHCP. In DHCP, we have something called relay agent DHCP. The word relay is something to call representative, something remote, do the job on your behalf. For example, I have a router here, that's router here, router there. This is Sydney, this is Melbourne. And now my network here, and we do not have a DHCP server here. We do not have a DHCP server, but we have one in Melbourne. We do have a DHCP server in Melbourne, and I want the IP from here. So what to do? We want to send a request to Melbourne. Can you give us a DHCP IP? So what we do, we send this one into another router. We call that relay. This one do the job in your behalf, something like a proxy. We cover here before the concept of proxy, something similar to that. So the application level gateway, it acts as a proxy. So to do the work on your behalf, take the request, send it, and get you the allow or not allow, whatever it is in here. So if I want to authenticate someone, easy. You give me the username and password. I'm not gonna authenticate it myself. I'm gonna send it to the relay agent. The relay agent will send it to the server, the AEEE, whatever it is, and the authenticated and come back. Does the work? Does the work. What's the problem with that? Delay, and what we call that overhead resources consuming. So I'm not authenticating that device or that user or whatever by myself. I'm sending around to be authenticated. Okay, so we can use that in different type of application, telnet, FTP, SSH, maybe not, because that's highly encrypted. However, it work with different type of applications. Now let's go back to the state inspection firewall. What that in state inspection firewall? Are you familiar with maybe not, I'm not sure. What is that? When I type netstat here, well, it gives you the list of the established connections which running on your system. Really, yes. So what is the foreign address? What is the local address? As you can see here, most of my local address is here, 127, except when it come to you here, guys, those ones, the Oracle VirtualBox and so on. However, those ones, as you can see that, these are my connection with you currently right now. Yes, I have different type of connection, but that's mostly the 192, the 168, 50, 53, 235, whatever. That's from my local IP. That's my IP. And that one, those ones, my ports. The ports, as you can see that 2534, 25, whatever, and more than 1023, as you can see those. So that's my local. What about those ones? That's usually, if I'm not mistaken, the 52 is the Zoom. If I still remember correctly, the 52, that's the Zoom meeting. 172, whatever, I have here a UTS opening connection as well. So the idea of that is we having tracking the connection between my device to the remote device, or from in to out. What type of connections are established in my computer right now? We have the same concept here. The state inspection firewall establish and maintain the connection from inbound and outbound. How that works? Watch that. So now someone want to visit Facebook. Okay, we want to visit a Facebook. The user want to visit, here it is. So we establish connection, and that's the filter, allow that, the firewall allowed that to go. No problem, no problem. Now that data, if I request something from the Facebook, log in, whatever it is, the data has to come back to my computer. Okay, so I cannot grab all the IPs which I'm visiting and I put it into the packet filtering, because that didn't make sense. Packet filtering, if you know a list of IPs you want to allow or blocked. So if you want to block IPs, or if you want to allow IPs, but you have the list of those ones, yes, okay, no problem with that. But if I want to establish connection from I visit Facebook, CQ, whatever it is, and MIT, whatever you want to visit, I don't have all the IPs to all those ones. Even if I grab all those IPs, most of those servers, they have more than one IP address. So it didn't make sense to keep listing IPs. That didn't make sense. What about if the server changed the IP address? It didn't make sense. So when we come to the state firewall, the state connection firewall, that one, if you establish connection to somewhere, it allow the coming back traffic from that establishment, let's say, connections. So whatever it is, this is maintain the directory established from the outbound, the TCP ones. Only allow incoming traffic that match the profile of an active established, highlight this one, established connection. So out, you pass through here. When that connection tried to give you data, yes, allow that. That's it, because we established that. We have established that. And sure, this one actually, it has an advantage as well. If you're familiar with the TCP, we mentioned that here before, the sequence acknowledgement. So that type of firewall, the state inspection firewall, it can follow and track the sequence acknowledgement of TCP, which is, in my opinion, that's a lot better than the IP one. The application, that's the cover one. And the last one, which is the circuits level. Circuits, the word the circuits, or the IC circuits in hardware, usually it represent something open and close, open and close, open and close. That's the circuits. We call that circuits. Something like the phone. Um, when you call someone, the landline. When you call someone, you establish a VC, a circuit. When you finish, it goes away, disappear again. So that's the same concept. It works something in the session layer. If you familiar with the 7 layers still, you may remember those ones. We have application, presentation, and then the session layer. If we have if you are connected to the bank account, usually someone, after a while, if he didn't use it, it been terminated automatically. We call that the session expired. Okay, so which means that someone or somehow that connection being monitored. Yes, we do not do that with the firewall. We don't do that with firewall. We have services and and servers to do that. But the main concept here, you have a connection, that circuit level gateway, establish TCP connections, and usually one in, one out, and keep it for a while. And sure, you have TCP, UDP, whatever it is, but TCP, UDP, that's layer 4. However, this one work on the session layer. Some traffic which been allowed to go through. However, this one focus on not the traffic itself, not didn't focus on scanning the traffic. It didn't. Or even if it does with a low level. The main focus here with the circuit level gateway, the connections, to establish TCP connections in and out for a while. If it's work, it finish, didn't finish. So if it finished, terminate. And it used something which is excellent. Maybe you have heard about that, maybe not. We have a protocol called SOCKS. As you call, is like you call it like socket secure, by the way. Socket secure. Socket means IP plus port. The word socket in TCP or layer 4, that means that IP, the same like the one I just show you here, like this one. When you have IP plus like this, IP and port, we call that a socket, those ones. IP plus port. So we have a protocol called socket secure or SOCKS. What we need that protocol for? That protocol actually use the proxy server. The proxy server usually work on that's the internal network, and I'm sitting here. I want send a visit abc.com. So I send it over here to the proxy server, and the proxy server will search for me where it is. That's the proxy server, by the way. So the out people, the out devices, the external devices, they do not know me. Nobody knows me, but they know the proxy server. So that's a level of security, which is excellent. Don't get me wrong. SOCKS, which is that protocol, the secure, secure, or security can work with the proxy to get the data. Or in short, it route through a proxy. So what happened exactly? If you try to have a protocol to cross the proxy and goes outside and get you the data and come back, that's not going to be an easy task. Why is that? Because the proxy usually changes the IP. Proxy usually changes the IP, and then the proxy itself send the request, and the request based on the router will choose the path. No, when we use the SOX protocol or the socket security protocol or secure protocol, that protocol is designed specifically to work with proxies to route through it. An easy task. And that's the good question usually. Where we put the firewall. If I have a firewall, where we usually put it? Well, if you have a personal computer, that's the antivirus software, you have it in your computer. If we have a server, we have something called host-based firewall, and that's usually as well individual host and servers. However, the servers, it has something, yes, it's, don't get me wrong, it's a software still, but it's advanced software with something called endpoint. Endpoint antivirus firewall, but we call that endpoint, which is can control tens, hundreds, thousands, tens of thousands of devices at the same time with something called endpoint. But anyway, it's still a software as well. In many books, most of the books, they combine those two together under host-based firewall. There is no personal and host, but in some books as well, they put it different classification. The external firewall or the internal firewall. So, okay, internal firewall, if I want to scan something inside, which is okay. It's work with rules. Rules means, like, for example, I work for CQ. Okay, I'm inside the campus. I want to access some specific resources. Can I? No. I can access some specific resources. Yes, no problem with that. What about if I want to access something else? Oh, here, the internal firewall, it will check my credential, privilege. Are you allowed to go through? So what is your rule here? Oh, I'm the lecturer. All right. Okay, do you want to access the tutoring? No. So, okay, I'm the tutoring as well. Oh, okay, at that time we allow you. That's how it is. That's work like that. So we have internal firewall. We put it inside, but that's mostly based on privilege. Yes, we can put an internal firewall to stop traffic from one department to another department, from one section of the network to another section. Yes, we can do that. But still, as the same thing, as I said, it depends on your rule and privilege. Still, the most one we use, the external firewall, as you put it outside like that. Like this. That's my internal network. I put it over here at the edge of my network, which is okay, outside the router. All right, that's okay. So not inside, outside. Yes, we can do that. That's the external one. However, even with the external one, we have a system, a design to do so. We have something called DMZ, which is, in my opinion, that's excellent approach. How many of you, for example, you can access models? You do. You access the model for CQ. Everybody can access that. Here it is. I can access that very easy. That's the model from CQ. Can you access your email? Yes. Can you access other resources we give you already? Yes, no problem with that. Can we access internal data from the CQ? No, you can't. Really? Yes, that's how it is. So how we do that? Here it is. This is usually the internet. You come in here and let's assume that this is the CQ network inside internal network. So what we usually do here. Okay, so at the beginning, you come into me over here. Yes. Let's put some firewall. And that's firewall number 1. You cross that, you find a router. Then you pass another firewall. Really? Yes. Then in most cases, you have another router. So another one, another. Why we need that? A lot of companies, they do like this. This is my external network, the company, the CQ external network, or the DMZ as we call it. So this is DMZ. What is that? Oh, here it is. I'm gonna put here any server or any services I want anyone to access. Like what? Web server. The web server, which is the cq.edu.au. So for example, if someone want to see that around the whole world, just type over there cq.edu.au. Anyone can access that anytime, anywhere, 24/7. So did they need permission to do so? No, nobody needs permission to have something like that. So that's a web server. What about the email server? Yes, if I have an email server, I want to use it internally as well. I mean, externally myself, not Outlook, not Microsoft. It's okay. I can put it here. What about FTP server for some material for my students or anybody else? Yes. What about if I have any audio, video, whatever recording over here? Yes. Whatever you want. If you have anything which is not that highly secure and you put it for users to be able to access that from anywhere. We put it over here in something called DMZ. I can put here multi-type of services, multi-type of servers, whatever it is, it's over here. No problem, no problem. Easy as like that. So how's that works? Oh, the first firewall here, it check the packet when it arrive. Where is your source? Where is your destination? Okay, are you going to the LAN, which is the internal, or are you going to the external? Okay, if you go to the external, good luck. Here it is. And it is not, we put it for everybody to watch or access, whatever it is. Okay, so no problem with that. What about if I want to go internal? Here it is. That's the rules of the second firewall. The second firewall, now this one will check your authority, your whatever, who are you, or your IP, or if you're using the state firewall, whatever the type of firewall is. But here, are you allowed to go in or not? So if you're not allowed, it's gonna direct you here. If you are allowed, it's gonna take you over here. We call that the DMZ. The DMZ has different type of designs. However, that's the main basic design of the DMZ. Something like that. That's the internet. It goes to the router, from the router to the first firewall. The firewall, do you want to go to the internal or the DMZ, or you want to go to the internal? If you pass that firewall, okay, so we allow you to go to the internal. If you don't, here it is. So you're going in or out. That's the whole concept. This is the similar to exactly the same way. You come across, first firewall check, you in or not. Oh, so you're not one of us. So you want to go to the in or out? Okay, I want to just to go to the web services. Here it is. You direct you here and take you over there. What about if I want to go to the internal? You go to the second firewall. The second firewall check you. Yes, yes, allow you. No, no, is not. We call that the DMZ, and this is another design for that. So a router, the edge router, a firewall. From the firewall, you have a DMZ for a second firewall, and from here you go cross. So in short, you need, if a hacker want to got to pass only one firewall. If you pass this one, you can get inside. Is that good design? Another design. That's about the firewall, or firewalls in general, the four types of firewalls we need to cover for today. We have another piece to cover, another concept, which is the VPN. But before we jump to the VPN, do you have any question? Before we go to the VPN, anyone has any question? Most use, it depends on, I do not have any statistics one, but according to what like my experience with the companies and corporates, they use mix of those ones. Mix. So for example, you have some certain networks like CQ, for example, and we have some application to work as well. So we use a mix of packet and application. Some corporate, they have a lot of in and out traffic, like SSH or VPN, whatever it is. They use the state one, so which is in, like establish, and so on. So the one which is usually filter high level of traffic, the state one, the one which is usually focus on providing some certain traffic. That's most of the company they use that, but in mix of other ones. But I don't have actual statistics which can tell you exactly which one is most used in the market. Yeah, that exactly like that. Just like it depends on the business itself. So some businesses, if for example the defense, let's say, let me give you an example. Defense, mostly they use IPs, the packet one, because they have certain IPs they want to allow, certain IPs they don't. That's it. So I want just those IPs only to be allowed, and the rest none. So any other IP will not allow. So the best option for them to have the packet one. Applications and all those, they go to the applications. Log in and log out a lot, they go to the states. Some companies and corporate, they mix between both of them, three of them, whatever it is, and so on. Depends. The second piece for today about the firewall, and that's actually having a hassle with the firewall, the VPN. We have a problem, a lot of problems when we try to apply the VPN, the firewall create hassle for the VPN to be allocated. What do you mean by that? What is the VPN exactly? What is the idea of the VPN? The VPN is like this, where it is, let me just show you. Now I have a company here in a branch of the company. Let's say, let's take the CQ. This is CQ Sydney. And we have CQ here, Melbourne. Now, we wanted between CQ Sydney and CQ, we have what you call it the internet, or what the ISP provider. Now the ISP provider is a public infrastructure. Public infrastructure. So if I have a company here in Sydney, for example, and I have two branches, I can, and they close to each other, I can put a cable, whatever it is, or type of communication between both of them to link each other, either wired or wireless, whatever it is. But I will find a communication way to communicate them securely. But if they're close to each other, but if in city to city, state to state, whatever, how I do that, I have to go through the terrestrial or ISP provider, whatever it is. But the ISP provider, public infrastructure, which means that everybody use it, which means as well, my packets mix with your packets, mix with anybody packets, pass through routers, different routers, many. So, and a router handle and process millions of packets per minute. So how I want to make sure that how I provide a secure connections or secure transportation of data between Sydney and Melbourne. We have something called T1 and T2, whatever it is, all those ones, which is you rent a channel. You rent a channel, a VC, not actual physical cable. No. You rent a VC. So we call that T1. And we have different type of those ones as well, communication, and you pay per kilobits, whatever the kilobits is. Okay, so that's one way of doing that. But you actually rent per year or 6 months, whatever it is, the whole, and you have to pay for the whole amount. Okay, so, but do we have something else? Oh, now if I want to communicate securely between one place to another place, or between individual to a place. For example, if I want to communicate right now from home, or from my office, or from whatever, from anywhere to the CQ, the servers. So we have, as you can see, that's AnyConnect, Cisco AnyConnect. So I need to go using that's a VPN from my computer to the VPN servers or server, the CQ one. We call that client to site, a client to site. So I want to communicate from whatever the location I am in to Rockhampton, to Sydney, to Melbourne securely. I'm using that. So that's client to site. Okay, so what is that? It secured the communication between an individual like me to the server. What about if I am here in Sydney, and I want to secure the whole communication between the campus in Sydney and to the campus in Melbourne. We call that site to site. That's site to site or client to site or host to site. So one to a site or the whole site to the whole site. What it does exactly, those ones, it the VPN has techniques of the component, by the way, of the VPN, usually client, server, and what we call tunnel. Tunnel, yeah, tunnel. Do we have actual tunnel? No, we don't. That's virtual. So, for example, that's here. This is Sydney campus, and that's Melbourne campus. We create a virtual tunneling here. We usually represent it like that. So that's a virtual, by the way, that's virtual. We call that tunnel. And we usually communicate, we can configure that with something like GRE or VPN or IPsec and many things. The VPN approach is, I want to create a highly secure communication between one device to another device, or one device to a site, or from one site to a whole site. What's in? You have a client, you have server, we have a server like as the one I just show you. I need to connect to the CQ VPN server. As you can see that, the remote, the New South Wales edu like this. So I had to go through that. Okay. And then we have the tunneling, which is the configuration. So what we call it, the configuration. And we have algorithm, different type of algorithm. Why is that? Because the traffic between this one and that one, highly encrypted. Not just highly encrypted. Encryption, we have something called keys. We use different type of approach like protocols. Let me just show, I put you a couple here. Maybe if you want to see those ones. We have something, those like IPsec, the KRI, the SSTP, those ones protocol for VPN. We can use them as well. So those not just only an encryption, more than an encryption. It provides encapsulation, hashing, key generating, and something like IPsec, for example. IPsec, it generates a key, different key per packet. Every key, every packet has a different key. So if you actually manage to, as a hacker, to catch a packet, and even if you crack the key, what do you got? One packet. That's it. That's it. And has nothing to do with the second packet, and so on and so on. It is not just only an encryption. So it's more than an encryption. We use different algorithm, different protocol, different approach to implement the VPN. But the main idea of the VPN, I want to create a secure communication over a public infrastructure. What type of, I put you something from mine here. This is, for example, branch to branch. That's how look like the IPsec if we want. So you have a server here, a server there, communication router to router, and we start, you have to configure both of them to be able to communicate. Something, if you want from remote, someone sitting here, communicating with the heart, like for example, like me, I'm sitting somewhere in the office. I want to communicate with the main headquarters in Rockhampton, and I can communicate here with the same thing, like that, remote. How that works exactly, you have what we call it the VPN tunneling. What is the VPN? That's someone sitting here, and want to communicate to the corporate. This is the CQ and this is me. That's my IP. I want to communicate here specifically. So what to do? Usually create a tunnel. The tunnel already, you will not create it yourself like that, but in general, when you run the software will create itself, try to create a tunnel. And you put the username and password, authenticate here, and start the tunnel establish. The tunnel is a temporary circuit, a VC, virtual. So it's temporary. As soon as you finish whatever thing and you terminate the connection, it disappears. Something like this, that's a site to site. As you can see that on here, we configure the router, and on that one, we configure the second router. They talk to each other and everything become encrypted and everything become highly secure. Really, that's a good one. What type of VPN we are using? We have the hardware, we have a software, we have a cloud. Hardware, I put you just only an example of the ASA. We call that ASA in Cisco. That's a small device like that. I didn't put you the rest of the photos or the image, but just only you put in and out. It has something like in and out. And those ones, inside that device, there is a software for sure. The software, it not just a hardware. It has a software as well. We configure that as well. But it's one of the devices which provide high level of firewall and VPN security. I'm sorry, that's the ASA. The encapsulation, that's the encapsulate as well. Tunneling, that's tunneling. That's what we call the tunneling. Tunnel is virtual, yes, don't get me wrong. As well, it can send the data from layer to layer. Let me just explain that to you very quick. That's, let's say, here. 1, 2, 3, 1, 2, 3, 4, like this. So, for example, this is layer 3, and this is layer 3. This one can send the data from layer 3 to layer 3. No problem, no problem. So it can send the data from 4 to 4. Okay, no problem. However, that can send from layer 3 and layer 4 and layer 5 and layer like this. Keep going. So it send it here and it keep going from here to here to here to here. So it can send the data to the similar layer or above. That's tunneling. One thing sorry, I just show you the ASA, that's firewall, and I should put this one at the top. The hardware, the software, and the cloud. I just mentioned to you that we have a problem when we use the firewall with the NAT. A lot of problem happen when we try to cross the firewall. The VPN, one of the main problem with the VPN, which is a lot of companies and sometimes users, they don't prefer to use the configuration and the problem with it. So if you have, it's really complex when it comes to configurations and maintenance of that as well. So if you go for the VPN, you will find that it has a lot of sub configurations, sub concept, a lot. So you need to configure that very well, and someone has to be very professional to maintain that, and so on and so on. Not just one person, more than one person. If you have a site-to-site communication. So if I want to hear, let me just mention, we mentioned here as well, Let's assume this one. I want to send the data from this side to that side. Okay, to send the data, here it is. This one is 10 and this one is 10. Between both of them, public. So which means that this one has to be NAT. Translate from here. So assume this is 37.5.5.5. Okay, that's public. So any IP from here has to go to the 5.5.5. Here is the problem. When we put that into a highly encrypted encapsulation, it creates a lot of problem to get it back, to de-encapsulate. That's why we have two type of tunneling. We call that the transport mode and normal mode. So one mode which you can encrypt the whole data, the header with the data, and another one it encrypt only the data and leave the header for that reason, for that specific reason. So not to involve, not to encrypt the header which has the IP addresses from the net. I believe that's all what we need to cover for today. I hope that you actually get some knowledge and concept from that. I have added some um, materials here to give you a full idea, because some of those the materials being given, yes, it provide basics, very basic, but it didn't provide the whole, not the whole, even it provide a wider overview. Questions? 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 Any? Last call. All right, ladies and gentlemen, if you don't have any question, if you don't have anything, have a good one, and I'll see you next week. Thank you, Heath. Thank you.